Hello everyone. In this video, I'm going to explain few challenges questions on binomial coefficients. So before understanding or doing these questions, you need to revise my previous concept, binomial coefficients and the properties. The very first question is, if NC12 is equal to NC8, find NC17. So let's recollect one of the property here. What is that? If NCR, because N is here also N is there. So NCR is equal to NCS, then we can draw out some conclusions. R is equal to S, or we can also even write as N is equal to R plus S. So for finding NC17, we need to find the N value. So we can utilize this property for finding the N value. What it is? R plus S. So here R is 12, S is 8. So let's find out N value, 12 plus 8. So N is equal to 20. So now we got to know N value as a 20. 20C17 we need to find out. For finding 20C17, we need to apply the general formula of combinations. NCR is equal to N factorial by R factorial into N minus R factorial. So now N value is 20, right? So 20C17 is equal to 20 factorial divided by 17 factorial into 20 minus 17 factorial. This 20 factorial can be written in terms of 17 factorial, isn't it? We have learned in factorial notations. So how can we write this? 20 times, 19 times, 18 times, 17 factorial divided by 17 factorial into 20 minus 17 is 3 factorial. 3 factorial is nothing but 3 into 2 into 1. So 17 factorial in the numerator and the denominator get cancels. 3 6 are 18. 2 3 is 6. So denominator nothing is left. In the numerators, we have 20 times, 19 times 3. 19 3 is a 57. 57 2 is a 114. So 1140 is the 20C17 value. Let's see the next question. Find the value of 47C4 plus sigma j is equal to 1 to 5, 52 minus jC3. This rotated M, right? It's looking like a rotated M. We can read it as a sigma. Sigma means nothing but it's a sum of. So in the place of j, we need to put from 1 to 5 and find out all that sum addition. So let's expand this. 47C4 plus, first we will put j value as a 1. 52 minus 1. C3 plus 52 minus 2. C3 plus 52 minus 3. C3 plus 52 minus 4. C3 plus 52 minus 5. C3. So we started the j value, applying the j value as a 1 to the 5. Let's simplify this above expression. 47C4 plus 52 minus 1 is 51. 51C3 plus 50C3 plus 49C3 plus 48C3 plus, this is how much? 47C3. Yeah. Now, say this is 47, 47. N value is the same. And here, R values are different. And these two are consecutive. 3 and 4 are consecutive. So we know the formula. What it is? We know one of the property. NCR plus NCR minus 1 is equal to N plus 1 CR. So we will utilize this property. We will apply this property here. So what we can write these two? 47 plus 1. See R. R means big value. In 3 and 4, which is the big one? 4, right? So we'll take 4. And rest all same thing. 51 C3, 50 C3, 49 C3, 48 C3. So which is nothing but 47 plus 1 is 48. C4 plus 51 C3 plus 50 C3 plus 49 C3 plus 48 C3. Now see again, compare this again. Here 48 C4, 48 C3. These two are, this R is consecutive. 4 and 3 are consecutive and N value is the same. So we can write this as 48 plus 1. That means 49. 49 C4. So rest of the things same. 51 C3, 50 C3, 49 C3. Okay. Now again here N value is the same. So we can write this as 49 plus 1, 50. 50 C4 plus rest of the things as it is. 51 C3, 50 C3. Now again this N value is the same and R values are consecutive. So we can write this as 50 plus 1. So 51 C4 plus 51 C4, C3. Now again these two has N value same and these two are consecutive. So 51 plus 1, 52. So 52 C4 is the answer. 52 C4 is the answer. So this is the simplification of this sum. Let's see one more sum. Third one. If 28 CR is to 24 CR minus 4 is equal to 225 is to 11, then find the R. Then find R value. So solution part. So how can we write this? This is to is a ratio is nothing but a fraction, right? 28 CR, right? 24 CR minus 4 is equal to 225 divided by 11. So this is NCR formula. Since we know the NCR formula, NCR is equal to N factorial over R factorial times N minus R factorial. Let's apply. So 28 factorial, 28 factorial divided by R factorial into 28 minus R factorial. So if we do this also, one more fraction we will get in the denominator. So that fraction, we'll put the multiplication and reciprocate that fraction. So we will get R minus 4 factorial into 24 minus R plus 4 factorial. Minus of R minus 4 is minus R plus 4 factorial divided by 24 factorial. That is equal to RHS side same 225 over 11. First, I have written this 28 CR applied in this formula. Okay. Next 24, see r minus 4 is there, no. So that one if we apply in the denominator, we can write it as a, put multiplication sign and reciprocate this. So in this way we can write. Now we need to find out for the more cancellation part. Here 24 factorial is there. Here 28 factorial is there. This 28 big number can be written as a small factorial, right? So how can I write? 28 into 27 into 26 into 25 into 24 factorial. And r minus factorial, r minus 4 factorial is as it is. Okay. Next, this one can be written as 24 plus 4 is 28. 28 minus r factorial divided by, here r factorial. R factorial can be written as r into r minus 1 factorial, r minus 1 into r minus 2 into r minus 3 into r minus 4 factorial. Why I have stopped here? Because to cancel the r minus 4 factorial. Okay, then 28 minus r factorial, which is equal to 225 over 11. Now let's see the cancellations. R minus 4 factorial and r minus 4 factorial cancel. 28 minus r factorial, 28 minus r factorial get cancelled. And what more is there? Nothing. So now we will shift this 24 factorial also get cancelled. In this denominator we have 24 factorial, right? So this also get cancelled. So now what we will do, all the numbers we will shift it to the right side. Okay. And variables one side, r terms. I mean variable is here r terms one side and the constants other side. So let's shift. So I'm writing constants here. 28 into 27 into 26 into 25. Bring this 225 by 11. If it comes this side, 11 by 225, isn't it? Reciprocates the fraction. And here, these things in the denominator, if we get transposed to the other side, they'll come to the numerator. R times r minus 1 time r minus 2 times r minus 3. Okay. Now let's see the cancellations. 25. 5 table get cancelled. Or 25 table also we can cancel. Okay. 5 5 is a 25. 5 4 is a 20. 25 means 5 5 is a 25. So 5 9s are 45. This 9 can cancel 27, 9 3s are. So nothing left in the denominator. So now we got here 28 into 3 into 26 into 11, which is equal to r into r minus 1 into r minus 2 into r minus 3. What are these r's? These are consecutive numbers, r minus 1, r minus 2, r minus 3. This LHS side also we need to write it as a consecutive numbers. For that, first I will split into our factors. Then I will check for the 4 consecutive numbers. This 28 can be written as what? Prime factorization we will write. 7 4 is 28, right? So 7 into 4 can be written as 2 into 2. Already 3 is a prime number. 26 can be written as what? 2 13s are 26. So 2 is a prime, 13 also prime. And 11, which is equal to r into r minus 1 into r minus 2 into r minus 3. Now, what are the two numbers if we pair? If we pair, we can write it as a 4 consecutive numbers. We need to check. 11 already there. 13 already there. Can we make some numbers as a 12? Let's check. 3 2 is a 6, 6 2 is a 12. Yes, we can. If we multiply these 3 numbers, we can make it as a 12. See? And 7 2 is a 14. Yeah, we got here. So here 11 and these 3 together 12 and this is 13 and this is 14. So what is the highest number? 14 here. So 14 into 13 into 12 into 11 we can write, which is nothing but r into r minus 1 into r minus 2 into r minus 3. So compare the either side of the equal to symbol. This is r minus 3. This is r minus 2. This is r minus 1. And 14 is the r. Therefore, r value is equal to 14. So in this way, we can solve this type of problems. So for finding the more number of, for solving the more type of the questions on binomial coefficients, follow my videos. Thank you.